Hello Surveyatris. Welcome to the second video of the photogrammetry output series. And in this video, I will be discussing on digital elevation model, digital surface model, and the digital terrain model. The digital elevation model is a 3D representation of the terrain elevations on the Earth's surface. This is an example of digital elevation model in 3D, and this GIF is the same model in 2D. It also provides elevation data for each point on the Earth's surface and allows for the creation of 3D visualizations. Here in this GIF, you can see the elevation profile of the line marked on the map. Also here you can see the elevation of each point on the map while I am moving through the profile. Digital elevation model are an essential component in geospatial analysis and are employed across various industries, from monument and riverbed survey to land and corridor surveys. The digital surface model is a subset of digital elevation model and consists of the Earth's surface, including all objects like building, trees, electric poles, etc. This is an example of the digital surface model. The small round-like structures are the objects such as trees, electric poles, buildings, etc. The digital terrain model is a subset of digital elevation model and consists of the Earth's surface and excludes buildings, trees, etc. This is an example of the digital terrain model. And here you can see the objects have been filtered out and only the terrain is visible. This illustration gives you a more detailed view and understanding on the digital surface model and the digital terrain model. The black line is represented by the digital surface model, and as you can see here, it has taken the elevation of the trees, house, and the electric poles. The red line is represented by the digital terrain model, and it has excluded the elevation of the trees, house, and the electric pole. Next, we look at the different formats available in digital terrain model and the digital surface model in a photogrammetry software. I have opened a project in Surveyan Geo Workspace for this. Let us go to the Export tab, and here you can see the digital surface model and its outputs, as well as the digital terrain model and its outputs. I have already downloaded all the formats. First, let us see the GeoTIFF format of both digital surface model and the digital terrain model. I have opened QGIS, and this is the digital surface model, followed by the digital terrain model. Here you can see the objects like trees, buildings, poles, etc. getting filtered out. Next is the slope. Slope identifies the steepness. The lower the slope value, the flatter the terrain. The higher the slope value, the steeper the terrain. The red is the area having no slope, and the blue is the area having high slope. Similarly, we have the digital terrain model slope, which is also showing the red and blue areas. Now, let us see what GSD means. GSD is the ground sample distance. Let us check the GSD of the digital surface model. And here we can see it is having a GSD of 15 centimeter per pixel. Similarly, let us check the GSD of the digital terrain model. It is also having a GSD of 15 centimeter per pixel. Finally, we have the PDF format. This is the PDF of digital surface model, and this the PDF of digital terrain model. Also, in the elevation measurement tool, we can draw a line on the map and get the profile. Here you can see that we have got the profile, and this is the profile of the digital surface model. By clicking on this, we can also get the profile of the digital terrain model. Here you can see as I move the cursor on the profile, it is also moving on the line that we have drawn on the map. Thus, we get to know the elevation of each point on the line we drew. Also, we can export these points in a CSV file. And in the CSV file, we get the northing, easting, as well as the altitude and the corresponding latitude, longitude values of the whole profile. With this, we have come to the end of this video. I hope you have understood the digital elevation model and its subsets, and how the digital terrain model and the digital surface model differs from each other. In the next video, I will discuss the next important output, that is the point cloud. If you are watching the video for the first time, please like and subscribe. We will be adding more videos weekly. Click on the bell icon so that you won't miss any upcoming videos. And thank you for watching the video.